The Legend of Zelda Breath of the Wild is a treasure trove of visual effects that we can dig into, and the runes that Link uses throughout the game are no exception. The remote bomb goes off with this huge, gorgeous bright blue explosion with particles flying out in all directions. There are more moving parts to this effect than I first thought, and in this tutorial, we will use Shader Graph and VFX Graph together to recreate each component of the explosion and use the Unity animator to tie everything together with a tiny bit of scripting. I'm using URP, but some of these concepts should translate over to HDRP. First, let's analyse some footage of the remote bomb exploding and plan out the effect. It happens pretty quickly, doesn't it? The explosion starts with an extremely bright core and a few white rays blasting out from the middle. The main bubble of the explosion can be easily created with a default Unity sphere and a custom shader graph, but the rays can be better represented with a particle effect, and for that, we'll be using VFX Graph. For both the core and the rays, the main body appears white, but there's a strong blue glow, suggesting we'll need to use HDR colour. Advancing forward a bit, the core is no longer pure white, and we start to see a non-HDR blue portion take up most of it. The white hot edges of the core are still here, and they're distorted a bit, rather than appearing as a clean circle. If you have a keen eye, you'll notice that the bottom section of the white hot glow is physically intersecting with the ground, so that's another component of the shader graph we'll need to include. Plus, we have a few of these smaller rays starting to fire outwards. Our VFX graph will need to contain two separate types of particles. As we go through the effect, the core reaches a maximum size as the particles continue to fly outwards. The huge rays from the start are beginning to fade out. Here the bigger rays have disappeared entirely, and the core is becoming more transparent so that we can see there's a blue light on the floor. Eventually the core starts to shrink, and the second particle burst is starting to fade out too. The white hot edges are gradually fading with the rest of the core until eventually all that's left are the smaller particles, which disappear soon afterwards. Before we get started, thanks to all my Patreon supporters. This video is made possible by your support. To create the explosion, we will start by making a shader graph of the core, then a VFX graph of the particles. Lastly, we will tie everything together using animations, a light source, and a bit of camera work. First things first, in URP, go to your pipeline asset and enable depth texture. Write this on a sticky note and put it somewhere you'll see it because if you're like me, you'll always forget this step. Then, create a new lit shader graph and name it Stylized Bomb. Head over to the Graph Settings tab and change the surface to transparent and make sure two-sided is ticked because we need to render the front and back parts of the explosion core. There are two major components of this shader, the emissive light and the base color. As a starting point, add a color property called base color. The reference value is going to be important later when we set up the explosion animation, so I'll name it _base color. This color makes up most of the core in the second half of the effect, so by default we can make it blue with 50% transparency. Let's drag it onto the graph and connect it to the base color output on the master stack. For the emissive light, add a second color property and call it emissive color. For every property on the graph, I'll change the reference string using the same convention. This one will be called _emissive color. This color needs to be HDR enabled, and I'll give it a default value of a nice blue with a bit of emissive intensity. We'll be tweaking these values in the animation anyway. The emissive component of this effect is itself divided into two parts. First, there is a Fresnel effect on the outer edge of the sphere, and second, there's a glow around any section of the sphere which intersects the ground. Let's deal with the Fresnel first. Add another property, this time a float called Fresnel Power with a default of 1. When we increase this, the Fresnel appears smaller and vice versa. Shader Graph comes with a Fresnel Effect node, so we'll stick one of those on the graph and connect our new property to the power slot. There's just one small wrinkle. Fresnel kind of looks broken when applied to both front and back faces, so we only want to use Fresnel on the front faces. We'll use an isFrontFace node combined with a branch node. For a front-facing fragment, we'll use the Fresnel effect result, else we'll output a 0, meaning there's no Fresnel. Next, let's handle the intersections. The approach we'll use here is to compute the distance from the camera to the part of the explosion we're trying to draw, and compare that distance with the depth of the pixel already rendered at the same position. If the two values are within some threshold, then we class this part of the explosion mesh as an intersection and apply emissive color to it. Add yet another float property called intersection power with a default of 1. Like with the Fresnel, when this value gets higher, the intersection glow gets thinner. To get the distance of the existing pixel from the depth buffer, use a scene depth node using eye mode. Then to get the distance of the explosion pixel we're currently rendering, use a screen position node in raw mode. Then use a split node to grab the fourth component. By subtracting the second value from the first, we get an estimated distance from the floor, but we want values that start at 1 when the explosion rests perfectly on an intersection and get slower when we get further away, which we can get by using a 1- node. A saturate node clamps the value between 0 and 1. Then we can apply the intersection power using a power node. Finally, add this intersection value to the Fresnel value from before. If we continue the graph like this, then we would end up with a very orderly glow, but the emissive portions of the Breath of the Wild bomb effect are disordered and noisy, so we're going to add some noise of our own. The edges of the glow are also cut off like a cell shaded effect, so we will be applying a threshold to the emissive light. Add two float properties, one called noise scale with a default of 100, and the other called threshold with a default of 0.1. Using noise in shader graph is made easy because it includes a few noise nodes. We'll just use a simple noise and apply the noise scale property in its scale pen. If we multiply our previous calculations by the noise, then we end up with a noise cloud pattern with a smooth fall off, so we can use a step node with our threshold property in the edge pin to provide the cutoff we were looking for. All that's left to do is assign the emissive colour to the correct parts of the image. We will add one final float property called opacity with a default value of 1. This is going to act as a global multiplier to the alpha output of the entire graph, which allows us to fade out the entire effect just by changing this property. The emissive colour is easy to deal with. Just multiply the output from the step by the emissive colour property and output directly to the emission output on the master stack. For the alpha output, we are going to toggle between the base colour alpha and the emissive alpha based on the output of step. First, output step into a lerp node in its T slot. When the step output is 0, we should be using the base colour alpha, so connect base colour to the A slot. When the step output is 1, we should be using the emissive colour, so connect that to the B slot. From the lerp node output, we only need the alpha component, so use the split node for that, then multiply by opacity, which is the global alpha multiplier I mentioned, and output to alpha on the master stack. That's the graph complete. At this point, we've successfully put together a compelling shader for the core of the explosion, so it's time to make a particle effect for the sparks. You may not have VFX Graph installed on your project, so go to Window, Package Manager, choose Unity Registry with this little button at the top and find VFX Graph, then install it. We can create a new effect by right-clicking in the project view and choosing Create, Visual Effects, Visual Effect Graph. I'm going to name my effect Stylized Sparks. Double-click it to open the VFX Graph editor. It's been a hot minute since I last talked about VFX Graph on this channel, so here's a very brief refresher. This is Unity's modern system for particles, and it runs on the GPU. The TLDR here is that VFX Graph is the way forward for almost every particle effect, except if you need them to collide physically, in which case you might be better off with the existing particle system. When you open a new graph, you're presented with a bunch of blocks, each of which control part of the particle effect. We won't need all of them, so go ahead and delete, from top to bottom, the constant spawn rate, set velocity random per component and the orient face camera plane, and the set size over life blocks. We will use this system to create the bright long lines that appear right at the start of the bomb explosion. In the spawn context, we control how the particles get generated. We want all the particles in the system to be generated at once, so add a single burst block. We don't need too many of these, so I'll use a count of about 8. Tweak this however you want. Moving down to the initialized particle context, we also set the capacity to 8. We want these particles to emanate in all directions, so we will make them spawn on the surface of a sphere. Add a set position shape sphere block, then expand arc sphere and sphere to change the radius to something small like 0.1. Now we're going to use a neat trick to orient the particles correctly. I'm going to give them a very small velocity pointing away from the origin of the sphere the particles are spawning on, which I'll do using a set velocity block. The neat thing about VFX Graph is that we can funnel values into each of these pins on the blocks like we do in shader graph. So move your mouse outside the system, then right-click and create node. We can grab the direction attribute of the particle, which is the vector pointing away from the origin, using getAttributeDirection, and multiply it by a tiny amount like 0.01, then output that to the velocity pin. Now I want to use a set scale block to stretch the particles so they appear like giant rays exploding from the origin, which I can set using the same direction attribute node. Use the tiny arrow here so we can select just the Z component and drag it out and multiply it by 500. Then expand the scale and output the multiply value to the Y component. The X and Z component should be about 0.5. To wrap up the initialized particle context, add a set lifetime block and set the value to 0.25 seconds. We want all the particles to fade out simultaneously. Only the output particle called context remains. You can text use soft particle if you want, but I'm not actually going to change the texture because the system looks fine with the default surprisingly. Add an orient along velocity block, which is going to determine the direction the particle chord faces in 3D space. As it turns out, because we already gave the particles a tiny velocity along their spawn direction, the orient along velocity block is perfect. Finally, we can set the color over life. Like with shader graph, we can add properties to VFX graphs using the blackboard, but the types are different and, praise be, we can add gradient properties, and they can be modified outside the graph environment. I'm going to add a gradient property called emissive color, and its default value will be an emissive blue with a very high intensity of about 9, which tapers off after 33% towards a non-emissive blue with 0 alpha. Drag it onto the graph and connect it to the color field on the last block. We're close to being done with the effect. We want to make 2 particle systems on this single graph, so select everything we've made so far and duplicate it, Ctrl-D on Windows, then drag the new system to the side. This system will be used for the smaller sparks which fly out of the center. Most of what's left is just tweaking values. First, change the burst size and capacity to about 50, then in the initialized particle context, raise the velocity multiplier to about 12 and the size multiplier to about 10. This time, we want the particles to move, so these values will make the smaller particles explode outwards quite quickly. Change the x and z size components to be about 0.15 because they should be much thinner than the giant ray particles. We're going to replace the set lifetime block with a set lifetime random block with values 0.5 and 1 because we don't want all these sparks to disappear simultaneously. In the update particle context, we will add a gravity block which does exactly what you'd expect. Now, the small sparks will follow a natural arc as they explode outwards. And that's all the changes we need to make, so the graph is complete. Just a note, you can name the 2 systems by double-clicking the name inside the dotted line at the top. The last stage is to piece the effect together. This bit isn't shadery or particle-y, so I'll rush through this a bit. Pause and replay bits of this video if you're following along. The project is available on GitHub if you want the specific values I used for this effect. First, add an empty game object named Stylized Bomb, which acts as the animation root, and as a child of it, add a Unity sphere, then apply a material which uses the Stylized Bomb shader. Drag the stylized spark particles onto the hierarchy as another child of the root, and finally, add a new light under the root object and make it blue with an intensity of 50 and a range of about 5. Then raise it slightly. Select the root object and create a new animation clip called Bomb Explosion. The animation is 50 frames long, and I'm about to say a lot of numbers at you, so you'll probably need to pause the video quite often. The bomb sphere scale will start at 0.5 and grow to about 4 by frame 10, then 4 to 3 by the end of the effect, so it looks like it rapidly expands and then slowly shrinks. The mesh renderer's base color alpha stays at 0.5 until frame 10, then falls to 0 by frame 50, so it fades out over time. For the emissive color, the alpha falls from 1 to 0 linearly by frame 50. The other components stay constant until frame 30, then fall to 0 by frame 50. This keeps the glow looking bright until just after halfway. The threshold property, which is controlling how large the Fresnel and intersection are, is 0.01 until frame 5, so the start of the effect is extremely bright. By frame 10, it's 0.2, so the effect stays relatively bright until it's fully expanded. Then it raises to 0.5 by the end, so the emissive section gets smaller over time. Finally, the light intensity starts at 50 and falls linearly to 0 by frame 30, and the light range expands from 0 to 5 by frame 10, then it falls to 2.5 by frame 30. Explaining animations is really tedious, but hopefully you're still with me. I'll end with a couple of short scripts to tie the particles and camera into the effect. The camera script, called Camera Controller, is something I wrote quickly to shake the camera up and down whenever the explosion happens. I'll only explain it briefly here. It's taking an animation curve and using it to apply a Y offset to the camera position over the course of a coroutine. The particle script is called Stylized Bomb and is attached to the animation root. The start explosion function here plays the particles and makes the camera shake. Back on the animation, we can call this function on frame 1 by right-clicking on this tiny ribbon at the top of the dope sheet and selecting Add Animation Event, then in the inspector, select Start Explosion from the dropdown. When we enter play mode, the bomb should constantly loop the explosion animation forever and the particles should restart each time. If you're looking for more effects based on Breath of the Wild, then see these 2 videos on cel shading and geometry based graphs.